everyone, in this video let's discuss how to solve the beam search algorithm problem in artificial intelligence and machine learning. So same like the best first search algorithm also, it is a uniform and a heuristic technique. Heuristic technique means the priority will be more for the less heuristic value. The priority will be more for less heuristic value. So this one you must keep in mind while solving the problem. Now what I will be doing is, I will be differentiating the best first search and beam search. So if we compare and learn, then we can understand much easier. So in the best first search algorithm, what we used to do, we used to see the diagram. There will be given the straight line distance. You can call it as the Euclidean distance or the heuristic value. So what we were doing, we were using the Q data structure here and we used to write the result here. So we used to write result here. So if you start from A, that is if you consider A as the initial node, from A you can move to B, from A you can move to C, from A you can move to D. From A to B, from A to C, from A to D. This is at the level 0. So only one element was there, so I inserted it in the queue and I used to take it out from the queue as the result is of A. Next, B, C, D is here. So who will be getting the priority first to be in the queue? So who will be having the less heuristic value? Find the heuristic value of B, it is 32. For C, it is 25. And for D, it is 35. So first it will be C, next B, next D, according to the increasing order of their heuristic value. First C of 25, next B of 32, next 35 of D. So this is of level 1. In level 1 we should choose only one. So in level 1 we should choose only one element to go to the final state using the initial state. So we should choose the less heuristic value path, that is C. So C will be written in the result. From C, if you see, from C I can go to E or I can go to F. I can go to E or I can go to F. If you see the heuristic value of E and F, E is having heuristic value of 19 and F is having the heuristic value of 10. So among 10 and 19, which is the smaller value? F. So you will write F first, then you will write E. This is of level number 2. In level number 2, you must choose only one element among the F and E. So F is having the less heuristic value, so you will choose it and write it in the result. Now, from F, I can only go to G because I can't move back to D since D is already travelled. From F, I can go to G and its heuristic value is 0. G heuristic value is 0. So we have reached the goal state from the initial state. If you see here, goal state G was given. From A to G, B to G, C to G means the heuristic value of A, B, C, like that. So it will be calculated up to the goal state. Since G was my goal state, we have reached the goal state like this. Now, you came up to the G, no? So insert it into the queue and G is the final result. Because this is at the level 3, we are having only one element. It will be inserted in the queue and directly in the result. So A was my initial state and G was my final state. From initial to final state, now I can. But in the beam search algorithm, there will be a set limit, that is beam width will be given. Beam width will be given or you can consider. Let us consider the beam width as 2. So what beam width as 2 will refers to means, so you are setting the limit, that is 2 best paths will be chosen. If you see here, same Q and same result will be there also. Same Q and same result. Same you will be writing the Q here also and you will be writing the result also. So the initial state is A. From A you can move to B or you can move to C or you can move to D. But since my beam width is 2, you will be choosing the best 2 condition or the paths to move to the final state. So we will be having the best condition, less heuristic value. So from A, you can move to B, C or D. You will be choosing the paths with the least heuristic value. C is having 25, B is having 32, D is having 35. Among these three, which are the two smaller values, 25 and 32? Among these three. So B and C will be selected. B and C. So the heuristic value of B is 32 and C is 25. Write them in the queue. So this is the level 0. In level 0 only one element is there. Write in the queue, write in the result. In level number 1 we are having two elements. So who will be written first in the queue? Less heuristic value. That is C will be written. Next it will be B. Next, to move to the next level, we will be using the C. So you must write C in the result, and C, from C I can move to E or I can move to F. Only two condition, and beam width is also 2. So you can consider both of them, E and F. The heuristic value of E is 19 and heuristic value of F is 10. So here the values are there. E is 19, F is 10. So what you will be doing? You will be inserting F first, then you will be inserting E, because F is having the less heuristic value. So in this level, that is level 2, you will be selecting 1 to move to the final state. That is, you will be selecting F because it is having less heuristic value. From F you can move to G. The only condition is from F you can move to G. You can't go back to D because D was already traversed. Since it was having the more heuristic value in the level 1, we not considered it. So from F to G with the cost of heuristic value 0. Heuristic value is 0. In level 3 we are having only one element, that is G, which will be written in the queue and will be written in the result also. If you see here, the result is same in both the best first search and beam first search, but the queue size, if you see here, queue size is less in the beam search algorithm. That is, it optimizes the time complexity and the time to solve a problem. So hope you understood how to solve the beam search algorithm problem. There will be a certain beam width which will be given, or you can set it, and according to that only you will be solving the problem. If you have any doubt regarding this topic, please do comment below. I will clarify it. If you liked the video, please do subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.